We will now be solving the last four questions from exercise 11.3 on the chapter of volume of a cone. So the last four questions, the first of them is question number 6. We are given that the volume of a right circular cone is 9856 centimeter cube. If the diameter of the base is 28 centimeters, find the height of the cone, the slant height of the cone, and the curved surface area of the cone. Okay, so let's write down first of all what is given. Now we are given the volume. So volume equals 9856, that is 9856 centimeter cube. We are given the diameter of the base, so the diameter equals 28 centimeter, and from the diameter we can calculate the radius of the base. So radius r is half of the diameter, which is d over 2, so that's 28 over 2, so we have the radius as 14 centimeters. And from this we have to first of all find the height of the cone, the height h of the cone. Once we have calculated the height of the cone, we can then calculate the slant height, which is denoted by the letter L. And then once we have calculated the slant height, we can then proceed to calculate the curved surface area of the cone. So we are given the volume of the cone. So what is the formula for the volume of the cone? Volume of cone is 1 upon 3 pi r square h. So we are given the volume. So on the left hand side we will have 9856, and that is going to be equal to 1 upon 3. Pi is 22 by 7, so we'll write 22 upon 7 into r square. We have the value of the radius as 14 centimeters, so it will be 14 into 14 for r square, 14 into 14 into the height h, which is the unknown quantity with unknown value that we have to calculate. So we just need to keep the height on one side and move all the other numbers that are available with us to the other side of the equal sign, and we'll be able to calculate the value for the height. So I'm going to keep height on one side, so we'll have h on one side, so it will be 9856 into 3 into 7. So we are moving all the numbers from the right hand side to the left hand side here, and then rearranging the entire equation by keeping the h to the left and all the numbers to the right. Okay, so the 3 at the denominator here, when it goes to the other side, it becomes it goes to the numerator. Similarly for the 7, it goes to the numerator, and all the numbers on the numerator will come to the denominator. So we'll have divided by 22 into 14 into 14, and we can solve this to get our answer for h. So clearly we can have this 7 cancelling out this 14 two times, so it's 22 into 14 into 2, so 9856 into 3 divided by 22 into 14 into 2, and that gives us a value of 48. So that's let me write that in black again. So we'll have it as 48, and since all the other dimensions are in centimeter, so the height h is also going to be in centimeter. So the value of the height is 48 centimeter. Okay, rather than just writing down the answer as 48 centimeters, someone has asked how did we do this calculation. So let's just simplify this expression further before I write the 48 there. So we can have further this 2 going into 98456. So we'll have 2 4s are 8, remainder is 1, so 2 9s are 18, and then 2 2s are 4, and 2 8s are 16. So 4928, and in 4928 we will have 14 going into that, so we can have 14 3s are 42, the remainder is 7, 72, 72, 14 goes 5 times in 72 with a remainder of 2, and then we'll have 14 2s are 28, so 352. And then we can simplify and see if 22 goes in 352. So we can simplify this further by dividing both the numbers by 2. So 2 goes in 22 11 times, and 2 will go here. 2 1s are 2 times, and the remainder is 1 1 5 15. So 2 7s are 14. The remainder is again 1. 1 and 2 is 12, so 2 goes 6 times. So we'll have 176 here. So we'll get it as 176 into 3. Let me write that in black again. So 176 into 3 divided by 11. So again we'll have 11 going into 176. So 11 goes into 176 16 times, and 11 ones are 11, so it's 16 into 3, and we get 48 as the answer, which is our 48 centimeter, which we had previously obtained as well. Okay, so it's the same thing, but we have just shown the working of the calculation here. So we have 176 into 3 divided by 11, which simplifies further, and we get 48 centimeters for the height of the cone. Okay, so now that we have obtained the height of the cone, we can now calculate the slant height of the cone. We know the formula for the slant height L. Slant height L is equal to r square plus h square under the root. So we have, what is r square? The value of r that we have is 14. So r square is 14 square plus height h. We have just computed the height as 48. So we'll have 48 square, and that's under the root. So we can calculate what is 14 square and what is 48 square. 14 square is 196. And 48 square is 48 into 48. So when we multiply 48 with 48, we get 2304. 2304. So now the sum of 196 and 2304 is 2500. So we have the slant height L as the square root of 2500. What is the square root of 2500? We have to find that number which multiplied by itself will give us 2500. That's the meaning of square root. So the number that multiplied by itself gives 2500 is 50. So it's basically we can write this as square root of 50 into 50, and we have seen the process of square root. When we have two same numbers under the square root, we can take them out of the square root and get rid of the square root and keep the number only once, right? So the value of the slant height L is basically 50 centimeters. Okay, so we have now calculated the slant height of the cone as well. That's the second part of the question. The third part of the question is to calculate the curved surface area. So curved surface area is equal to pi r L. So we have the value of L, we already know the value of R, and we can substitute pi as 22 upon 7 into the value of R is 14 into the value of L, which is 50. So it's 22 upon 7 into 14 into 50, and when we multiply these numbers, we get a value of 2200, and since it is area, the unit is going to be centimeter square. All the dimensions are in centimeter, so therefore the unit for the area is going to be centimeter squared. Okay, so the curved surface area for that particular cone is 2200 centimeter square, which we obtained by performing this calculation: 22 into 14 into 50 divided by 7. So we can do some simplification here. The 7 goes into 14 two times, So it's 22 into 2 into 50. So it's basically 22 into 100. So I'm just showing the steps here. 22 into 2 into 50 is 100. So 22 into 100 is 2200 centimeters square. Okay, so that's the curved surface area of that particular cone. Okay, we will now proceed to solve the next problem. That is question number 7. Okay, so in question number 7 we now have a right angle triangle. So that's a right triangle which is ABC, that is shown in the red line here. So we have a right triangle ABC with sides 5 centimeters, 12 centimeters and 13 centimeters. Now it is important how we assign the sides because it is a right angle triangle. We have to arrange the sides in such a way that the sum of the base square and the height square should give us the square of the hypotenuse. Okay, so we have to choose the side values appropriately. So if you notice, we will have 5 square plus 12 square is equal to 13 square. 5 square is 25 plus 12 square is 144, and that gives us 13 square, which is 169. So 144 plus 25 is 169. So therefore for this right angle triangle, the 13 side is the hypotenuse side, and the other two sides will be the two sides which are perpendicular to each other, which is one of them is the 5 centimeter side, the other is the 12 centimeter side. So the sum of r square plus h square should give us L square. Okay, we know that formula. So we have that's r square plus h square equals L square, that's hypotenuse. So what we are told is that this right angle triangle is rotated about the 12 centimeter side. That means if we keep this line as it is, the 12 centimeter side line as it is, and rotate this triangle in one of the directions, what is the shape of the solid form? So if we fix this line, the 12 centimeter line as it is, and rotate this entire triangle about the 12 centimeter side, so this edge B will rotate along this circular arc or the circular path, and it will form a cone for us. Okay, so we will have a cone being formed by the rotation of this particular right triangle about the 12 centimeter side, and the height of the cone so formed will be the same 12 centimeter, and the radius of the base of the cone will be the 5 centimeter side. Okay, so the radius is going to be 5 centimeters. So when such a triangle is rotated about the 12 centimeter side, the base radius of the cone so formed is 5 centimeters, and the height of the cone is 12 centimeters. This is what we have to understand as to which is the base and which is the height, and correspondingly, once we know that, we can calculate the volume of the cone. So volume formula, let's write down volume of cone is 1 upon 3 pi r square h. So we now know all the values that we need. So it's 1 upon 3, pi is 22 upon 7, and the radius of the base is 5, so it's 5 into 5, and the height of the cone is 12 centimeters. So we just need to simplify this and we will get our volume answer. So we can do the simplification. So the 3 here will go into 12 4 times. 5 into 5 is 25. 25 into 4 is 100. So we are going to get 22 into 100 divided by 7, which is 2200 divided by 7. So that will give us the volume of the cone so formed. So we'll get the answer as 314.285 centimeter cube. Okay, so that's the volume of the cone. We could have also kept the 2207 as pi as it is, So if we leave it as it is, it's the same as 100 into 22 over 7. 22 over 7 is nothing but the value of pi. Okay, so 22 over 7 is pi. So we can simply keep the answer as it is, as 100 pi centimeter cube, and both these answers are the same. Okay, so pi is 22 over 7. If we substitute and multiply, we are going to get 314.285 centimeter cube, or if we keep pi as it is, we will get the answer as 100 pi centimeter cube. Both the answers mean the same thing. So we have obtained the volume of the cone. Now, given that the right triangle ABC is rotated about the side which has a length of 12 centimeters, so that forms a cone which has a radius of 5 centimeters and height of 12 centimeters. Okay, now we move on to the next question, which uses the same right angle triangle, but the rotation of the cone of the right angle triangle is done about the 5 centimeter side. So let's see how we can calculate the volume. So in the next question here, we are given the same triangle ABC as in the previous question, and this time the only difference is that the right triangle is revolved about the 5 centimeter side. So we have the same 5 centimeter, 12 centimeter sides as the two sides perpendicular to each other, and the hypotenuse is 13 centimeters. So it is the same triangle that we had in the previous example, except that this triangle is rotated to the right side by 90 degrees. So it is pushed to the right. So we have the 5 centimeter side as the height now. And when we rotate this triangle about the 5 centimeter side, we get a cone which has a base radius of 12 centimeters. So we'll have a cone formed which is having a base radius of 12 centimeters and the height will be 5 centimeters. So again, we simply apply the formula for the volume of the cone and substitute the values of the radius and the height, and we get the volume of the cone. So volume equals 1 over 3 pi r square h. So it's 1 over 3 pi. We are going to keep it as it is now. R is 12, so r square is going to be 12 into 12, and the height of the cone is h, which is equal to 5 centimeters. So we get, we can simplify this. So 3 will go in one of these 12s 4 times. So we'll get 12 into 4, 48 into 5. So the answer for this is going to be 240 pi centimeter cube. So we'll have it as 240. So that's 12 into 4 into 5 is 240, and we have the pi as it is times pi centimeter cube. So we have now calculated the volume of the second cone as well, where the right angle triangle is rotated about the 5 centimeter side. So that gives us a cone whose base radius is 12 centimeters and the height is 5 centimeters. Okay, and from that information we have now calculated the volume of the cone so formed. Now the final part of the question is we are asked to find the ratio of the volumes of the two cones obtained in question 7 and question 8. In the previous question, we had the volume value as 100 pi centimeter cube, and the volume here is 240 pi centimeter cube. So the ratio of the volumes is going to be, so we'll calculate the ratio now. Ratio of volumes of the two cones. In the previous case, we had the volume as 100 pi. So it's 100 pi divided by the volume in this current problem is 240 pi. So the pi and pi will cancel out each other. So we have pi cancelling with pi. So we end up with getting 100 over 240, which is 10 over 24. So we can cancel out one of the zeros here. So the 0 and 0 will cancel. So it's 10 over 24. And we can simplify that further. So 2 goes 5 times in 10, and 2 goes 12 times in 24, 5 over 12. We cannot simplify this any further. So the ratio of the volumes is 5:12. Ratio of volumes of the two cones is 5:12. Okay, so we have calculated the ratio of the volumes. Again, whenever we have to calculate ratios, it becomes easier if we keep the pi as it is, and that way we don't have to perform some extra calculations. We leave the pi as it is in our expression, and then when you take the ratio, the pi will cancel out, and that will save us some time because we don't have to do some additional multiplications and divisions which involve the value of pi. Okay, so that's what we have done. That's why we kept the volume of the previous one also in terms of pi. If we substitute and get the value, multiply and get the value of the volume, it's not a problem. We can still do that and get the same answer, but it simplifies the calculation if we keep the pi as it is, because it's going to cancel out anyway when we are taking the ratios. So now let us move on to the last question of exercise 11.3, which is question number 9, where we are given that there is a heap of wheat which is in the form of a cone, and it has a diameter of 10.5 meters. So that means the diameter of the base of the cone is 10.5 meters and the height is 3 meters. So we are asked to find its volume. So given is the diameter and height. So from the diameter we can calculate the radius. So given d equals 10.5 meters, so radius r will be d over 2. That's half of the diameter, which is 10.5 divided by 2 is going to be our radius. So we'll keep it as it is, or we can simplify that and we get 5.25 meters for the radius. The other parameter given to us is the height h. So height h is given as 3 meters, and we have to calculate the volume of the cone because the heap is in the form of a cone. So therefore we have to compute the volume of the cone. So volume of cone, and again we use the formula for the volume of the cone, which is 1/3 pi r square h, which is 1/3 into, so instead of writing volume of the cone, we can say volume of the heap of cone. Okay, cone heap. Okay, the heap shape is cone. So 1/3, and that's 22/7 into radius is 5.25, which is 10.5 divided by 2. So we can write 5.25 into 5.25 into the height is 3 meters. So we can go ahead and simplify this calculation. We can perform all these multiplications and we will get the value of the volume as, so we will get the value as 86.625, and since it's volume, the unit is meter cube because all the dimensions are given in meters, so the volume is going to be meter cube. So we have computed the volume of the conical heap of wheat. The next part of the question says that we have to cover the entire heap by a canvas to protect it from rain. That means we have to cover the entire curved surface of the conical heap of wheat. So that means we have to calculate the curved surface area of the cone. So the canvas that will be required, it will have the same area as the curved surface area of the cone. So the area of the canvas is basically going to be the curved surface area of the cone. So the curved surface area is obtained by the formula pi r L. Of course, we don't know what is the value of L, which is the slant height of the cone, but we do know the radius of the cone as well as the height of the cone. So from the radius and height, we can calculate what is the slant height L. So the slant height value, let's write down the formula. So I'll just write it in a separate box over here. So the slant height L is square root of r square plus h square. So we know the value of r. So r is 3 meters, so it's 3 square plus h is, r is 5.25, so it's 5.25 square plus height h is 3, so that's 3 square, and we have to compute the square root of that. So that gives us the value of the slant height. When you do that calculation, we'll obtain the slant height value as almost 6.05 meters. Okay, so the slant height L will be obtained as 6.05 meters once we perform this particular calculation over here by using the formula for the slant height. So once we have obtained the value of slant height, we can substitute that in our formula for the curved surface area. So we'll have now pi is 22/7, so let me write it here. That's 22/7 into radius is 5.25 into the slant height, which is 6.05. So we can simplify this and we will get the value for the area of the canvas, which is the same as the curved surface area of the conical heap. So we can do some simplification. This 7 will go into 5.25, 0. So we'll have 52 7 7s are 49. The remainder is 3. So 35. That's 7 5s are 35, right? So we'll have 7 going into 5.25, 0.75 times. So we'll get the simplified expression as 22 into 0.75 into 6.05, and when we perform this multiplication, we will get the value for the curved surface area as 99.825 meters squared. 99.825 meters squared. Okay, so that gives us our solution for the area of the canvas that is required to cover the entire conical heap. So that area of the canvas is basically the curved surface area of the cone. Okay, why we do the curved surface area? Because we are just going to cover the top of the conical heap. We are not going to cover the bottom circular area of the conical heap. So therefore we are interested only in calculating the curved surface area of the cone. Okay, so that brings us to an end to exercise 11.3. We will move on to the next exercise in the next video, where we will be talking about volume of spheres and hemispheres. Okay, so that will be the last exercise of this particular chapter on volumes of cones and spheres.